MacBook Air, and it's an A1466. Says no power. As usual, the first thing we want to do is take out the back screws. That way we can identify the state of the device. So the back screws on the device are missing. Okay, screws are out, and we have a missing screw here. That may suggest that the device has been in for repair. Okay, and the JTAG connector, because it's small, we can from here we can conclude that this is 2015, 2017 because of the JTAG type that it has. The next thing we want to do is we want to confirm what's the state of the device. Now, because we can see there is no signs of liquid, then we can then go ahead and connect our charger. Okay, we have charger communication, which will tell us that indeed we definitely do have PP3 before too. It also tells us that we have PPDCN, because if we didn't have PPDCN, we will not have charger communication. We do have PPDCN, we have PP3 before too. The next thing we want to confirm is we want to see, and also it also tells us also at the level of the at the section of the SMC in terms of charger communication, the SMC is not in reset mode. Okay. If the SMC was in reset mode, the light will not be uh, amber, rather the light will be green. And one of the ways we can confirm that that's exactly what the case is, if the light was to be green, would be for us to disconnect the battery, because the light being green may also indicate that the battery is fully charged. But that's not the case. We have the light on the charger, it's amber. So the next thing we want to do is we want to see what we have on our PP bus. Switching the meter to voltage mode, black probe to ground, and then red probe on our fuse. By the way, let's open up the board view. So the port is going to be 820-00165, 820-00165. Remember, guys, that I said that the 2015, 2017, they uses the same board view. They uses the same board design with very subtle differences. However, the physical boards, 2015 and 2017, are exactly the same thing. Everything that you can use for 2015 board, you can as well use for the 2017, including the SMC, which is usually a board bed. For example, you cannot use a 2013, 2014 SMC on a 2017, 2015. You can, however, use a 2013, 2014 SMC interchangeably. 2013 will work on a 2014 and 14 on the 13. But when it comes to 15 and 17, only 2015 and 2017 in terms of the SMC will work interchangeably. Um, so that said, the next thing we want to confirm is, let's see what we have on our PP bus, which we can get on the fuse here, this F7140. So the reason why we want to see what you have on our PP bus is because if we have 8.2, for example, we're supposed to have 8.5, 8.6. If we get 8.1-ish, 8.2, it tells us that SMC is not running. So it gives us a direction as to exactly where to go. Now, if we do find that we have the SMC, if we have 8.6, for example, then we know that SMC is running. Now, the next thing we would then do is we would now come see what we have at R8133, because then again we want to confirm if we have our source rail, which is the pp3v3 underscore source. So we confirm if we have that. Then, depending on what we get, that will determine where the next step that we take. So we want to start by confirming that we have our PP bus. And then another thing is oftentimes, so sometimes you may have a short on your PP bus, but the short is going to result from either of the tantalum capacitors on the logic board. Especially in this area here, you have on the caps on pivos underscore S5 underscore HS computing. If you have a short there, what will happen is your fuse will blow out, which is exactly what it's supposed to do. When the fuse blow out, when you are checking for your PP bus, you may measure on one side of the PP bus and then you get your voltage, which is 8.6. Try to measure on the other side as well, because if the fuse is blown, you may not know, and then you may obviously just start troubleshooting, but not knowing that okay, you only have problem of the fuse being blown because there was a short. And also, whenever you have a short in a nature like that, let's say that we have a short and PP bus, and then the fuse blows out, but after you replace the fuse or before you connect power to the machine, ensure find out why the fuse blew in the first place. Because oftentimes when that happens, you will have a no short on one side of the fuse and then a short on the other side of the fuse because of the tantalum cap. So what you want to do is before you apply power onto that board, make sure you confirm that there is no and then this procedure is the same also for backlight repair. You have a backlight repair and then you have a short on one side on a fuse and then the fuse blew. So this is not the same in terms of when you have a shorted cap, for example. But then in a situation where there was a short and then the fuse blew out, so what you want to do is after you replace the fuse or after you decide to redo the fuse, which is like using a tiny wire to make sure it fit into the same rating of the fuse, because you don't want to use too thick of a wire, which would defeat the purpose of the fuse. So you want to make sure you have confirmed that there is no short on the other side of the bridge before you apply power onto your board. Because if you do so, what will happen is you may end up having the same issue, especially when it comes to a backlight. You may end up a simple repair on the MacBook Air, for example, the 2017 design up until 20, say, before the redesign. If you have a short, just like the one we're working on here, if you have a short on the backlight line, which is the backlight output, and then the highest voltage on the machine will obviously be the backlight output, which is going to be about 20 something to 30 volt, depending on how much brightness you're having on the screen. So if you are not cognizant of the screen cable might have created a short on the line, and then what happens is it blows out the fuse. Now, if you just put by the fuse, or you put a wire on the fuse, and then you just connect to your cable again, and then you apply power. This time, the resistance may not be as the first. The resistance may be kind of more, and then it will then blow out your cable. Then what's then going to happen is now you have to open up the screen to replace the cable. But if you had and then another thing, sometimes it's when you are measuring for a short, especially if on the fuse, when you're measuring for a short, for make sure that the screen cable is connected. But sometimes the short may be present because of the screen cable. So you make sure the screen cable is connected, check for a short, because if you measure for a short without the screen cable connected, and then you connect your screen, obviously you bypassed the screen short. So make sure your screen is also connected. That is also helpful. So that said, now let's move on to see what we have on our PP bus. Are you able to get? Do I need to move it forward? Or are you able to get it?
Yes, but I think it's much better if
You should say something, Peter.
you zoom in.
Is it in what?
Like when you're working on the screen, you put it 2 times.
So let's say black probe on ground and then red probe on one side of the fuse. Let's see what we have. We have 7.6. That's okay. And then on the other side of the fuse, what do we have? We have 7.6. So that basically tells us that first, we don't have a short on the PV bus, and then secondly, we also do not have a short. Our SMC it's perfectly running. And then by the way, the reason why we have 7.6 is because the battery is connected. If the battery wasn't connected, we will be having 8.6 instead. Okay, so 8.4. Okay, let's just confirm that. See what we have. This to be sure. 8.41. Hmm. That is strangely low. So what we want to do is, let's say if let's remove it and then connect it back. So it's not too low to be 8 point. Let's see that again. Yeah, that's exactly what we should be getting. So we were caught up with the previous data from the battery being connected. That's why. So 8.6, that's exactly what we should be having. 8.6 and not 8.4. Yeah, 8.6, that is what we should be having. And that's because now, so the previous time when we had 8.4 or 8.7 point was because the battery voltage was present. Now the next thing let's say we want to do is we want to see if we have our source. So let's see if we have the source rail present here at R8133. Let's see what we have. Okay, so we can see that the source rail is not present, so that is 0 volt. Now that gives us an idea of where to go to. Now the source rail, it's going to be partially generated from the clock chip as well as SMC. So now we want to and then before that, let's confirm if we have PP3 V3 underscore S5. Let's see if that is present. Yeah, that is present. So the next thing we want to do now is we want to take out our board and see why our source is not present. And obviously, in doing so, before we've checked to see why our source is not present, we obviously want to confirm if we have the clock signals as well as. So what we will be checking is the rails that are supposed to be. So before we, as you guys know, your schematic, it's pretty much like language, you know. So there has to be if I say to somebody, how are you, and the person responds, I am fine. So there has to be some kind of interaction between the sections of the secretary. Otherwise, you obviously will not get exactly what you're looking for. So before we worry about the source being not being present, we want to find out why. We want to find out if what is required for the source to be generated is present. So we take a step back. We don't just worry about we don't just exactly we take a step back to find out why, and then generally when you check in, oh, that was hanging, so it means it's one of the one that fell from here. So generally when you are so the general rule in terms of a missing rail is this. So Laura, please let me have a book and book and a pen. Yeah, no, the one on top. So at a general rule, this is how you guys should do it. So if you let's say we have a particular rail, let's say PP 3v3 underscore source that is missing. Yeah. Now the general rule is this. So when this rail is missing, the first thing you want to confirm is so A, you check is it present. You check if the rail is present. If it's not present, now the next thing you want to do is you want to come to that section of the rail. Now if this is a section of the rail, before you continue, now you check, do you have a short on the line? Now you want to see if you have what? Have a short on the line. Now if you don't have a short on the line, the next thing you want to do is what is the condition of that circuitry? Physical inspection, you inspect it. Yeah, you inspect it. For example, if it was like if it's a liquid. Now obviously that would mean that you have been able to narrow down the section of PP3V3 underscore source generation circuitry where it's being generated from. Then you go to that section, physically look at it. Is there any cause for you to blame that, okay, this may be the reason, now after that, if let's assume the board is clean and I have checked, I don't have a short, the next thing I want to do is I want to find out, because in that rail that I am looking for is an output, correct? Okay, now because it's an output, Now, the also the also there's the rules in terms of output is there has to be input, correct? In order for you to get output, because you have to give something to be able to get out something from the other side. Yeah, beginning of something, you have to apply something to get something out. So there has to be input. Now, this is the section that controls the output of pp3v3 underscore source. The next thing I want to do before I blame the section itself, now I want to check my inputs. How are my inputs? Are my inputs all in place? Now, after I've checked my inputs being in place, which generally would be sometimes a power line and sometimes a signal, correct? Now, after I have confirmed that that is in place, the next thing I want to do is I want to go for the on switch. Now, this on can either, so usually it will be referred to as EN, which is enable signal. After the power, now I want to find out the enable signal on my on switch. You understand? I want to find out if that is present. Now, if this section has also a reset underscore L signal, I also want to find out if this section, if this is also what is also in low mode or high mode. So now I've checked. I checked to make sure that I don't have a short on that line. Afterwards, I checked to see that my inputs are in place. Now, after that, I checked to find out that my enable signal is present. Now, if that circuitry has a reset, then I also find out if this signal is what is high or low. Because if this is pulled down, then that would explain to me why this is not working the way it should work. Now, if I then find out that this is actually high and not, and by the way, so R is going to be at the opposite of L. So reset L, it means that this section, this circuitry will be in reset mode if this is low. So which then means that they should be high if I don't want this circuitry to be in reset mode. Now, what reset mode will do is it will basically prevent your circuitry from being active.
All right.
Peter, are we still communicating? You have a problem there?
I was checking if I'm getting also.
So the opposite of R, you find sometimes you find L or sometimes you find R. So now reset L, so it should be high, but when it is low, it tells you that that circuitry is not going to function because the section is what is low. Now, after that has been confirmed, if I confirm that it's reset underscore L is high, I confirm that my enable signal is present. I confirm that I don't have a short on the line. I confirm that my inputs are there. The next thing I want now, I can now blame the chip itself. Why? Because everything that's required for the chip to be active, it's present, but it's still not working. So that I don't know if you guys understand now. So before you can, yeah, go ahead. Yeah. Yeah.
So when it
Don't worry about don't worry about this. Usually when you find reset underscore L, that is it's just gonna be reset L. So yeah. So don't worry about the
under normal circumstances, like under normal conditions, when it says reset low, my signal should be high.
Yes.
For the secondary to be completed. So that
Yeah. So then you have to so when it says reset L, so what it says is that circuitry that has that that has that a combination of reset L will be in reset mode if the signal is what is low.
Okay.
So generally the low would be 1 point something volt, 2 point something volt. You understand? I mean, in fact, sometimes you may, because this generally the pull up would be 3 point, let's say 3.4 volt, for example. You may sometimes have 3.0.
So which means it's very low.
Not low. It's in between. It's not low. It's almost complete. So usually what happens in sections like that, you might find now. Let's now say that this signal is low. The next thing I want to do is I want to see where is my reset connected to. Where does it have ties with? So let's say I have, let's say A here, and then C, A, B, C. Now, what then I want to do is, and then I want to find out, because sometimes the reset can be pulled down from in or out. It can be pulled down from incoming or outgoing.
Okay.
You understand? can be pulled down. But obviously, after we've confirmed that this is not the case, that's not the case, that's not the case. And how do we do that? We do this by using the annihilation protocol, which is basically to remove from the circuitry. Because if this can be pulled down by CAB, if C is not in the circuitry, A is not in the circuitry, B is not in the circuitry, then nothing else should be pulling it down. Now I then have to worry about where it's being generated from.
Okay.
Now, if after this it's in place, I still do not have my output, then I can now blame this chip. Now, another thing also that I also will now want to confirm is this. Sometimes my this rail, my line, the source line, maybe you may be getting instead of let's say 3 volt, 3.3 volt, you will get 3 to 1 volt, 3 to 1 volt, 3 to 1 volt. That tells you that you have a short
On the
on the line.
on your source now.
Yeah, you have a short on that line. Now the caveat is it may be that also may also be that the chip itself.
It's faulty.
No, 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 not that. I'm just going to read it back now. The chip may be a problem. It may also be that to enable signal, it's present and off, on and off. That's why you see it start to create it, and then so it may be an enable signal. It may also be that you have a short on the line, but you can confirm that, which is just basically to see what if you have a short on the line. If you don't have that, check your enable signal to be that your enable signal is basically not fluctuating. Because if it's fluctuating, that is the result that you will get. And also, you also check the input power lines or the signals to that chip. And once that is done, then you will be good to go. But like I said, so it is where you are that will determine the next phase that you move to. You understand? So it's important that you understand where you are. Identify the sections where that particular rail that you're looking for is being generated. And then another very important thing is you need to know because, for example, say this is PP3V3 underscore source. Let's say this is PP3V3 underscore SO. Now you need to know when is this rail supposed to be generated. That is also very important. Now, SO, for example, would mean that the device is on. Now, you don't want to look for SO rail when the device is not on. So you also need to know when is this rail supposed to be present. Any question before we move on? Okay. Any question before we move on? Okay, so now, so we did confirm that our source is what is not present. So the next thing we want to do is we want to basically remove our board, and then so sometimes you may find a situation whereby you may need to. There are some machines that you see whenever. One of the reasons why it's always advised to just remove your battery is it gives you room to find out if you have a problem here. Always check here if you have corrosion on the other side of the trackpad, because if you have corrosion on the other side of the trackpad, you may find a situation whereby where if that is the case, what our multimeter would give us usually would be that we will have our source volt, we'll partially have the SO rail, or even sometimes you may have the SO rail on this line fully, but then the machine is still not going to start. So, but and that state is it's basically pulling the seat, and that state is being made possible, or it's remaining that state because of the trackpad cable. So the next thing we want to, so always make sure you remove your battery. It gives you a better room, and then you can also confirm to see this. And also, obviously, when you do this, because of oftentimes, if you are not the one who took the machine apart, the person putting it together may not remember or may not, because there is no direct reason why this should be disconnected. So they may just put it back without having to put that, and then one of the ways you can easily tell that you've messed up in terms of your trackpad not being connected is immediately your fan will go crazy.
I can see that.
Yeah, but the fan will not go crazy immediately.
Yeah, it will go crazy once the machine is fully boosted.
No. So when you look at your boot sequence, when you connect your charger, so there are two way. So when we have fan over spinning, I can really go in details in that. But just understand that when you connect your charger, the fan is not going to go crazy immediately. No. So it's going to start first. and then obviously when the sensor starts to fall in place, and then it registers a missing sensor because of the cable being not being connected, then you because of the tracker not being connected, then you can now get the fan becoming super high. So that is just one of the ways you can identify that your track fan is not connected.
You said also the machine comes very slow.
Yes, the machine will lag, but also it will be very evident because your trackpad is not even going to move at all. And another funny thing about it is sometimes your trackpad may actually move if it is that the trackpad cable is connected but not partially, but not completely connected. So you may have the trackpad moving, but also but that's your problem. And also sometimes the track the sensor itself on the track, for example, you see you see those. So you may actually have a problem on your trackpad. So, but these are things that you can actually find out. It's not something that boss. Yeah, I'm calling. I'm very busy. And you, what should you want me to do for you? Yeah, I was asking you about the 19. You say I have to count that's it. Because you are teaching, I thought maybe you are coming. Oh, okay. Recording. Yeah. The 19, you tell me. You let me know. Okay, not a problem. The other one I left it there. Okay. Okay, so now that the board is out, remember we want to find out why our source is not. Yeah. So usually, so after the board is out, now I want to flip my board to the side and do an inspection of the board. So let's do an inspection, and then at the same time, we try to dust our board to give us a better. Now that you're seated, are you still able to capture it? Peter, you are not old. You're a young boy. I don't understand how you already have. Do you have backache at this age?
This sickness, I will never get.
Peter,
the flu before.
you're around 20 years old, or even less than 20 years old, Peter. 19, and then you already having backache. What's happening? What's happening? Is it?
I think
Can you see why this is off?
yeah.
Peter always has excuse. Peter, you're supposed to be a lawyer. Seriously, and with you, because excuses makes you just settle for mediocrity. Everything you have excuse. Why, Peter?
Those are answers. If someone asks you something, you should give them answers.
No, man, you just have
It's not an
excuses.
excuse.
Peter, you have excuse for everything. That is okay. So, first thing we want to do a bit of a visual inspection on the board to see if there's any reason why our source. Okay, now I'm not sure. We didn't check to see if I was short on our source. So now let's check if we have a source on it. So the board is now out. The next thing we want to do is see if we have a short on our source. Source is going to be here. We don't have a short, and then we don't have a okay, and then we did confirm that we have that real present. Yeah.
Yes. Yes.
Okay. So the next thing we want to do now is let us see. Let's connect and then check again. Let's be sure where we are. Switch our multimeter to voltage mode. Let's confirm. Obviously, because we don't have the IO port cable connected, there will be no charger LED. So now, what we want to do is let's see what we have on. It's just to confirm that. Okay, 16.6. Okay, that's fine. And then this 3.4. That's fine. Reverse 3.6. That's fine. Source. Let's check our source rail. Okay, it's not present. Now let us because our source is so now let us go to our clock circuitry to see if we have all of the generation from our clock, which is U1900. So let's start from PPV RTC. Let's see what we have. So we can check that on the scabs here. We can check on this cap here, and then we can also check on the resistors here. So let's check to see what we have. We should get 3.3 volt at this section of the board. And then another thing, another thing is when you connect your charger, when you apply power to your board, you may also want to kind of feel the board sometimes. That's another, yeah. So if there's anything that it's, yeah, so that is considerably heating up, so that you can also pick up. So that's another thing you guys should be aware of. But also, usually depending on the type of issue you have, the type of problem you have identified that you're chasing, that will determine how you really follow up business. Okay, now let's see what we have on our PP3V3, our clock section. Okay, so so you see that our clock is not present. Yeah, PP3V3, the clock signal is not present. So PPV RTC is not present. So I hope you guys are following up. Okay, now just to confirm, let's see if we have PP bus still. Can confirm PP bus here. Alright, so we see that. Now, let's see. So here we don't have. Now, you saw how we're building it up. First, we checked if we have source is not present. We check if, and then we have, yeah, if source is not present, we want to go check the clock signal to see if the clock signals are present. Now, when the clock signal is not present, it's a little bit scary because, in terms, what I mean by that is, I, I usually when I have an issue with a clock line, it may be a very simple problem. At the same time, it may be a very difficult problem. A very difficult problem would be that the clock line is being affected by the PCH. That is a problem. So what the next thing we want to do now, we want to see if we have a short on our clock line. We just hope we don't have a short because short on clock. We have a short. So, okay, yeah, that's not good because a short on your clock.
It's mostly related to PCH or PCH, right?
What are you asking?
I'm saying a short on a clock signal line. It's
Go ahead. What's your
is
question?
is it more related to or it's being caused by the PCH itself?
No. It's not being caused by. So usually, when you have a line that is shorted, you need to see what are the affiliations of that line. What is that line? What communications are on that line? What is that line connected to? Now, if you see what that line is connected to, first we want to see. So you see, we have R 1300, 1301, 1302, 1303. Now, what is output of 1301? PCH underscore 13, then PCH underscore PCH underscore PCH, and then RTC reset L. Now, the if you see what it's so, and then the only thing else that is connected is going to be this RTC underscore L. Okay, obviously that is the main thing that we're worried about. Let's see what we have on the RTC line. Yeah, so this is where our show lies. So if we look now, the only other places where you can find it is this, and this, and oftentimes this almost never fail. But yeah, you yeah. So what we know now, the only lines where we have that, it's just gonna be this U1900. It's almost never U1900. Almost never U1900. Especially if you do not see a physical like a liquid damage in that section of the board, and and if it happened to be anything from here, then it's definitely going to be at our PCH. So what we want to do is, I mean, just for us, you know, for the audience, let's That's my tweezer, the one I use for the silver one. Did anybody take tweezer from my desk? But when you were cleaning, did you see tweezer here? The silver one.
So this
So where's my silver tweezer?
you can check through the test. And I think it's good. This one.
Okay, tell I did mention this before. Please, guys, just give my tools. I have very basic tools here in terms of, but I don't understand with you guys have packed tools in your desk. I don't see how you still have to take my tool. It's never the clock, but yeah. So what we just establish that we take this out. Okay, before we take that out, let's take out the caps here, which is gonna be one, two, three. Let's take that out. This cap, the one that was beside you 1900, it's almost never that. But just for yeah, just but it's like it's almost never that one, and especially because if it's not physically damaged. So what you want to do out of curiosity, let's just measure the individual caps and just see if we have a cause to blame any of the caps here. So let's check this one. Are we short on this? No, we don't have a short on that. We don't have a short on that. We don't have a short on that. So none of the cap is shorted.
Sure.
So if you check, we should still have our short present. So yeah, we still have our short present. Yeah, unfortunately, our short is still present. Okay, just the last thing, which, like I said, it's really not a. Let's just do it so that it doesn't seem as if we didn't do it. But oftentimes, clock. uh it would die. Not that it doesn't die, but to die in a manner that is shorted, it's not common.
Rare.
It's not.
Unless it's a little bit damaged or physical damage.
No, it's not impossible, but it's just not common. And obviously, when it comes to so this type of caps, they are non-polarized, so which means you don't have to worry about the orientation. There is no need to worry about what is pin one, what is pin two. You just place it in our law, and then you're good. So this is why you apply a bit of solder of that, so that you have a better smooth installation. So yeah, that is in place. The next thing we want to do, even though it's not, just yeah, it's very much the case of. So let's see what we have. It's too shorted. Yeah, it's too shorted. So unfortunately, as and because the other outputs that we have is just going to be this, and yeah, all go to the PCH. Unfortunately, so this machine, it's yeah. So which would also mean that the SMC, the CPU, obviously, because you cannot separate the PCH from the CPU, so the CPU just needs to be replaced. Now, at this point, this is usually where the client will ask questions like, "How did it happen?" I'm not interested in how it happened. I'm not interested, and I'm not gonna come up with guessworks as to how it happened. I can't be very much wrong in telling you how it happened because I wouldn't have proper data to support that. But I can tell you what is happening now,
What is happening?
which is exactly what you need. You don't want to go into the unnecessary to tell the person how it happened, which you may also be wrong. So why go into texture into something that you cannot?
Natural cause. That's what you were saying.
Natural cause, no. You just can't confirm, because that is the truth. You cannot confirm.
Yeah, that's what they do to human beings if they die. They just say it's natural cause because they don't want to go into detail.
Not that you don't want to go into details. You can go into details, but you want to stay with what is correct and what is incorrect. You know,
Yeah.
like you want to stay with, okay, yeah, this is because if you start coming up with maybe, sure. Personally, I don't like people coming up with maybes. If you don't have true data, then forget it. Don't tell me about maybes. What's happening?
Chargers.
China is not connected. What are you talking about with that?
It's testing for sure. So let me do
Yes, yes,
that.
You see what I'm saying? Why does it seem like the short is gone? Because I just checked. I just checked this now, and I didn't. That's what I'm just confused. Like, how can the short be gone? Let's just check that again.
Was it showing in short? No, it wasn't showing in short. The one which was showing in short.
That's a source line. Oh, I see what
Did
you
it give us a
say.
short? No, it didn't give us a short.
Oh yeah.
So we went to the
Oh,
other
okay,
line.
okay, 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 okay. Yeah, I was. Oh yeah, source was no shorter, so our short was on the clock. Ah, okay, yeah, yeah. So yeah, so pretty much this is unfortunately PCH and eesh, beautiful board. What was it? It was a 1.6. Okay, yeah, this was a 1. This was a 2015, another 2017. So now this board, basically you can use this board for pretty much every part here you can use, and then the only thing we did, the only way out to fix this board now is for us to replace the CPU. And if you don't have stock of that, it's just
But it
yeah.
can be replaced if you want to replace it. Right?
Yeah, once you have stock of it, you just need to replace it, and then reprogram the bio strip, and then you're good to go.
You can take from a donor.
It's preferred to use
To a brand new one.
yeah, it's preferred to use a new one. Mm, yeah, unfortunately, yeah, this is so this is yeah, it's quite sad that it has to be the PCH. It's quite sad it has to be the PCH. So another quick option would be we can just fix another board in place of this one. 2015 that is dead, but PCH is fine, CPU is fine. And just fix that in place of this, and you'll be good. So that would be another quick fix to this.
Ah,
But it's as if you never put flags on it.
Yeah, that is how you. That's a special cleaning technique that you learn from research lab. It's a special cleaning
It's like
technique.
you've never put flags on that board. It's like
That's a special cleaning technique you learn from research lab. Like old school technique. Old school.
then you just what is so
So you clean it in it. So that when somebody see the boy, be like, wait.
did you work on it?
Yeah,
These
it's
are actually cool.
yeah, it's an old technique you learned from old people. Not
No,
from